All right, back to it. Number 34. Wait, double check on my mic. Yes. Okay, consider the velocity vector for the particle moving in the plane. The position of the particle at 2 is 4, -2. What is the x coordinate of the position? All right, we got to do this. I'm going to put the generic formula. F of x equals the integral from a to x of f prime of t dt plus f of a. This is the formula you use when you're given a derivative and you want to find the position at f of something. And that's what we got to do right now. We need to find the position of the x coordinate at 0.5. So the integral to 0.5. We do have to use the initial condition. We know that at t is equal to 2, the position of the x particle is 4. So then at that point, you can just use the x prime expression, which is ln of t to the power of 4 plus 1. And again, this is a calculator question, so just plug it in. The answer here would be C. So the position of the the x coordinate of the particle at 0.5 is 2.059. 35. The function g is defined on the closed interval, and we know that g of 0 is equal to g of 2 and is equal to g of 4. The function g is continuous. Okay, it's continuous and strictly decreasing. Which of the following statements is true? Oh, that one's tricky. So we have a function from 0 to 4, and the only thing you can do is decrease. That's it. From 0 to 4, it's decreasing. However you want to draw it, you can draw it a concave down, you can draw it concave up, you can draw it linear. It doesn't matter, but it has to be decreasing. And it's kind of tricky because they say g of 0, it's equal to g of 2, and it's equal to g of 4. How in the heck is that going to happen if it's decreasing? And it's continuous. So you can put some values. They don't have to be on the x-axis because they don't say that it's they don't say that they're equal to 0. They just say they're equal to each other, right? So they have to kind of be on a horizontal line. What you can do is define it with an open circle. This function is decreasing and it's continuous on the open interval from 0 to 4. That's another big word, on the open interval, meaning the endpoints are not included. So which of the following is true? G has neither a minimum or a maximum. Actually, that sounds pretty true. According to the extreme value theorem, if a function is continuous on a closed interval, you are guaranteed to have a maximum or a minimum. But we don't have a closed interval. And by my drawing that I just did, we don't have a max or a min. But let's just check the other ones real quick. G has an absolute minimum, but it has no absolute max. No, that's not true. C is kind of like the opposite. G has both a max and a min. Okay. All the other choices, they say that we have a max, a min, or both. And we can't have them. So they could be true if one of the endpoints was included. Oh wait, it has to be a 4. If one of the endpoints was included, or 0 to 4. But just because one of the endpoints is included, it doesn't mean that it would still be true. Like it could be true, but there's no guarantees. Find the volume of the solid generated when the region bounded by the y-axis, y equals e to the x, y equals 2, is rotated about the y-axis. Here's my sketch. e to the x. Well, we're bounded it by the y-axis, so can I just draw this? That's e to the x by the line y equals 2. Here it is. And you want to revolve that with respect to the y-axis. So we're doing revolutions for horizontally, right? Like left and right. If you want to find the volume, it's the integral from a to b of the area of the cross section. What cross sections do we have? What two-dimensional shape do you get when you slice this three-dimensional figure? A circle. So that means we have to, what the heck? So we're gonna be doing the integral of pi r squared. But I wrote dx just like to keep it general, but in reality we're doing dy. We're revolving with respect to the y-axis. We have to differentiate with respect to y. A is my minimum, which in this case would be 1. I don't know if you guys know, but e to the x crosses the y-axis at 1. And the maximum is 2 because they told us. We just have to change the equation in terms of y. ln of y equals x. That's your function. So you have ln of y squared dy. And plug it in the calculator carefully. Let me see, what's the answer here? The answer is A.
Wait, it's not 2 minus the ln of y?
No, we're doing right minus left.
Oh, yeah.
Because the radius would be given by the distance from the center of revolution to the function. So the function is ln of y. The center of revolution is 0. Right minus left. ln of y minus 0. (37) The path of a satellite is given by the parametric equations. The upward velocity at 1 equals. So should we look at x prime or y prime?
What?
Y prime. Because we're looking for the upward velocity. And again, you have a calculator. Don't do it by hand. You can just do math 8. Math 8. Which is the derivative with respect to t of that whole thing. I mean, if you want to do it by hand, you could. You could write 4 cosine of t plus 12 cosine of 12t, but you don't have to, right? And then just plug in the 1. So the answer here is C. Yeah. Don't worry too much about getting the derivative. I still see students trying to do that. 38. If g is a differentiable function, where g of 1 is 4, g prime of 1 is 3, which of the following statements could be false? Okay, very conceptual question here. They're telling me g is differentiable. What else are they telling me with that word?
That is continuous.
That is continuous. Which means that, actually I'll do this. The left-hand limit will equal the right-hand limit because it's continuous. So here, option A, the limit from the right equals the limit from the left. Yeah, that is true. It's continuous, it's differentiable. The limit as 6 approaches 1 of the derivative is 3. I'll get back to that one. That's the answer. The limit as 6 approaches 1 is 4. Was it true? One. I don't know what the function is doing, so I'm just gonna kind of do this. The left-hand limit even if it's open, the right-hand limit will be the same. Is the points open or closed?
Open. So wouldn't it equal 4? I mean,
It's actually closed because it's differentiable. You can't differentiate something if it's discontinuous. So it has to be filled in. And we also know that g of 1 is 4. So the limit as x approaches 1 is 4? Yeah, it is 4. This one's true. D. That is the definition of the derivative. Definition of a derivative. They're saying the derivative at 1 is 3. Yeah, it is. We were told that. It's true. So then the last one has to be the one that's false. All the other ones, yeah.
why is that false?
The limit as x approaches 1 of g prime equals 3. Let's think about this real quick. My drawing right here is just a sketch, right? Because in reality, the graph should have been more like this. Kind of, I'm just trying to make a little line to show you that the slope is 3 at this point. But the limit of the derivative, the limit of the derivative is 3. That's a good question, and I think I might have to think about it a little bit longer. Yeah, I will get back to you on that. But at least I proved the other 3 were true. Yep. 39. Good, almost done. A particle moving in the xy plane. The position of the particle is given by x and y. What's the speed of the particle? Okay, our formula. You gotta get x prime and square it. Take y prime and square it. And then plug in the 3.1. Don't do it by hand. You can do it however you want in the calculator, like all at once or in parts, but do it with the calculator. And then the answer would be, where's my answer? C. Which definite integral represents the length of the first quadrant arc of this curve? Okay. The length of the arc is basically integrating speed. So x prime of t squared plus y prime of t squared. So because we're just selecting the integral, then I'm gonna go ahead and find the derivatives. X prime is just gonna be e to the t. Y prime, we got negative 2t. Right? Yeah, square it. E to the t squared becomes e to the 2t. Negative 2t squared becomes 4t squared. So that eliminates 2 choices. Now we have to find the limits of integration, and it gets a little tricky. That's what I thought at first, and I wasn't getting any of them. So here's the thing. In the first quadrant, x is positive, y is positive. We're given an x component. e to the t is always positive. E to the t is just always positive, right? No matter what. But y, based on what we're given, y is not always positive. So when is y positive? We're going to solve for t. We're going to add t squared to the other side, square root it. Which means that we have, I'm just going to rewrite the inequality from -1. -1 is less than t, which is less than 1. So, in order for this particle that is defined by two parametric functions, the only way we're going to maintain it in the first quadrant is if t is between -1 and 1. So let's see. The x component, we don't have to worry about that one. That one's always going to be positive. So there it is. 41. For which function is the Taylor series about 0? Okay. Unless you already know what this represents, I recommend that you guys get the terms out of this series. So like, for example, plug in 0. If you plug in 0, you're going to get, well, you're going to get 1 on top. Because -1 to the power of 0 and x to the power of 0. And even the denominator will also be 1. 0 factorial is 1. Now you plug in 1. You get -1 times x squared over 2 factorial. Plug in 2. The -1 becomes positive. So you get x to the power of 4 over 4 factorial. I'll do one more. Plug in 3. -1 to the power of 3 is -1 x to the power of 6 over 6 factorial. Do you recognize it? It's cosine. Cosine and sine have a very similar expanded series, but cosine has the even powers. The even powers, the even denominators. This was cosine. Sine would have been like this. It would have been x minus x cubed over 3 factorial plus x to the 5 factorial. So it was just cosine. (42). Another tricky one. The graph of the function f is shown in the figure above. Find the value of the limit as 6 approaches 0. Okay. If you follow your instincts and you plug in 0, you get f of 2. So we're trying to find the value as we approach 0. But by just getting the value for f of 2, we would get this problem wrong. So we kind of have to focus on this guy, the inner function. 2x squared plus 2x kind of looks like this. With a y-intercept of 2. Okay. Look, if I approach x equals 0, if I approach it from the left side, or if I approach it from the right side, no matter which way I'm approaching 0, I'm approaching it from a higher value, right? Like, if I just focus on this, the limit as 6 approaches 0 of 2x squared plus 2 equals 2. But again, we're approaching it from the higher values. We're coming from 3, from 2.5, 2.4, 2.1. We're approaching it from the greater values. So this part is telling me how to approach the limit. So when I go back to the regular problem, I'm approaching 2, but I need to approach it from the greater values, meaning the right side. And if I approach it from the right side, the limit is 3. That was a tricky one. Oh, let's go over here. 43. At how many points on the interval from 0 to pi does f of x satisfy the mean value theorem? Well, the mean value theorem says that the instantaneous rate of change needs to equal the average rate of change, as long as a function is differentiable on a closed interval. But because all the options have a value, that means that condition is probably true. So let's take the derivative. The derivative would be 2 cosine of x plus 4 cosine of 4x. And the average rate of change from 0 to pi would be f of pi minus f of 0 divided by pi minus 0. Just to keep my writing short, I'm just going to write f prime. But I already know what it is. F prime of x equals, okay, if you plug in pi, you get 0. If you plug in 0, you get 0. So, in other words, when does the derivative equal 0? You're going to have to graph it. But make sure you only graph it and you're focused from 0 to pi. How many times do you cross the x-axis? Or at least touch it? 4 times. I'll let you guys do that later on your own. Okay, 2 more. As a cup of hot chocolate cools, the temperature is given by h of t. If the initial temperature was 120, what is the average temperature during the first 10 minutes? Do you know what they want me to do when they say find the average temperature? They want me to find average value. Average value. So we got 1 over b minus a times the integral from a to b of h of t dt. As a cup of hot chocolate cools, the temperature is given by h. The initial temperature. No, that was just to throw you off. Yes, the. Oh, wait. I see that we don't have a complete equation. We don't have k. So what we should do is figure out k. So the initial temperature was 120, which means that h of 0 is going to be equal to 120. So k is 50. Now you can plug it in. That's what we needed at 124 to complete the equation for h. I didn't catch that when I was doing it the first time. I just thought average value, bam, set it up. The answer here is B. The last one. The rate at which purification process can remove contaminants from a tank of water is proportional to the amount of contaminant remaining. If 20% of the contaminant can be removed during the first minute, of the process and 98% must be removed to make the water safe. How long is it going to take? Okay. When something is directly proportional, we learned that we can set it up. We can set up a differential equation like this. But this is for exponential growth. This one is talking about removing things. So it's an exponential decay. It's negative. The reason why this helps us is because we can avoid a lot of work. Because the goal right now is to get an equation for P. P is just a random letter. If you don't know the rule, you're going to have to separate the variables. I'm going to erase this in a bit so you don't have to copy it. You would have to separate the variables, do your antiderivatives, solve for K. You would have to do a lot of messy stuff. But if you know your formula, the equation that goes with this differential equation is CEKT. Okay. So C is going to be the contaminant. The initial contaminant. We have 100%. We don't know how much we have, but we know the percentage. It's 100. If 20% of the contaminant can be removed during the first minute, that means that we have 80% left. We have 80% of the contaminant after 1 minute. This is going to allow me to solve for K. So, divide by C. Take the natural log on both sides. And divide by your negative. There's your K. Which means my formula is this. So now the main question. We need to remove 98% of the contaminant, which means we have 2% left of the contaminant. How long is it going to take for us to hit that? So make your equation equal to 0.2C and solve for T. 0.02 is going to be equal to E of the natural log of 0.8 T. These cancel each other out. And sorry, just kidding. They don't, because the T would be in the way. Yeah, they don't. I was like, wait, I'm not gonna get the answer like this. No, we gotta take the natural log on both sides. That's how we're gonna cancel out the E, leaving us with the natural log of 0.8 T. Yeah, my writing messed me up. Anyways, divide by the natural log of 0.8 on both sides, and you get the answer is approximately 17.53. So nobody says we have to remove exactly 98%, right? Maybe we remove a little more, wait the 18 minutes, the water is safe. Okay. A lot of questions. Thank you. Next up, we'll tackle the FRQs.